In this video, we're going to take a look at some examples of incorporating our angle difference for cosine. And we're going to start by finding the exact value of the cosine of 15 degrees. Now, we could type cosine of 15 degrees into our calculator, or cosine of pi over 12 radians, and it'll give us a decimal approximation. So what we're going to look at is how to use some exact ratios we already know to find the exact value for cosine of 15 degrees. So first of all, we need to find two angles that are going to subtract to make 15 degrees. So 45 and 30 degrees will work, as will many other angles as well, such as 135 degrees minus 120 degrees. So it doesn't really matter which two angles you select as long as they have a difference of 15 degrees. Now, in the last video, we saw that the cosine of the difference between two angles is the cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle. So in this particular example, I guess A would be 45 degrees and B would be 30 degrees. So we're going to take the cosine of 45 and multiply it by the cosine of 30, and then add to that the sine of 45 times the sine of 30. And we have exact values for these. Cosine and sine of 45 are both square root of 2 over 2. The cosine of 30 is the square root of 3 over 2, and the sine of 30 is 1/2. So we have square root of 2 over 2 times the square root of 3 over 2, and then to that we're going to add square root of 2 over 2 times 1/2. Well, multiplying our fractions, we get square root of 6 over 4 plus square root of 2 over 4, which, because they have like denominators, we can combine them and condense it to make the square root of 6 plus the square root of 2 over 4. So again, if you type in cosine of 15 degrees in your calculator, it's going to give you a decimal approximation. If you type this answer into your calculator, you'll get the same decimal approximation. So at least you can use that to help check to make sure you got the correct exact value. Example 2, we're going to verify that the cosine of pi over 2 minus theta equals the sine of theta. In other words, when we look in a right triangle, the cosine of one of the acute angles is going to equal the sine of the other acute angle. So expanding out cosine of pi over 2 minus theta, it's the cosine of the first angle times the cosine of the second. So cosine of pi over 2 times cosine of theta. And then plus the sine of the first angle times the sine of the second angle. So the sine of pi over 2 times the sine of theta. Now, cosine of pi over 2 and sine of pi over 2, we have exact values for. So cosine of pi over 2 is 0, so we have 0 times the cosine of theta. Sine of pi over 2 is 1, so we have 1 times sine of theta. And then 0 times cosine of theta is going to be 0, and add that to sine of theta, we get sine theta. All right, example 3, verify that the cosine of negative theta equals the cosine of theta. So in other words, if we evaluate, let's say, the cosine of negative 45 degrees, it's going to be the same answer as the cosine of positive 45 degrees. So we can think of negative theta as 0 minus theta. So setting up a difference here for negative theta, we get 0 minus theta. And now we can take the cosine of the first times the cosine of the second, so cosine of 0 times the cosine of theta, plus the sine of the first times the sine of the second, the sine of 0 times the sine of theta. And again, we have exact values for cosine of 0 and sine of 0. They're 1 and 0 respectively. So our first expression here becomes 1 times the cosine of theta, which is the cosine of theta. Our second expression becomes 0 times sine of theta, which is 0. So we have cosine theta plus 0 gives us cosine theta. Now, using some identities as well, we can actually verify each of the following here. So we're just going to run down the list. We're not going to verify each one of them. Pardon me. So cosine of A plus B, it looks identical to the one we've used for the difference, with the difference being that instead of having a plus in between, we have a minus. So whatever for cosine, if we're adding the angles, we subtract. If we're subtracting the angles, we end up adding. So it's just the opposite of what's in between A and B for the positive versus negative sign here. The sine of A minus B is the sine of the first angle times the cosine of the second. And then we keep that minus sign there and then do the sine of the second angle times the cosine of the first. So it's the sine of the first times the cosine of the second minus the sine of the second times the cosine of the first. With the sine of A plus B, it's the same thing. We just switch the minus to a plus. Tangent of A minus B is the tangent of A minus the tangent of B over 1 plus the tangent of A times the tangent of angle B. So with tangent, which is actually where this comes from, is the sine of a minus b1 over the cosine of a minus b1. When you simplify it all, and you get tangent of a minus b, or excuse me, tangent of a minus the tangent of b over 1 plus the tangent of a times the tangent of angle b. For tangent of a plus b, we're just switching the signs around again. So this minus in the numerator becomes a plus, this plus in the denominator becomes a minus. And again, note that the tangent of a plus or minus b is the sine of a plus or minus b over the cosine of a plus or minus b. So again, the tangent of a plus b is the sine of a plus b over the cosine of a plus b. All right, that about does it for this video. In the next one, we'll take a look at some more examples. So I'll see you then.